So, we can talk about WebRTC. So whilst I'm talking, if you can make sure you're signed in on the Wi-Fi and you've got your Chrome ready, because at the end we're going to have a little mass participation demo. So I'm Tim Panton. I got bored with business titles, so I thought Protocol Droid was about right. Because I really like writing protocols, but I also like explaining technology to people. So it seemed like both things seemed to match. Dan is officially the chief ape at the Nimble Ape, and he also works on Bespoke. So we wanted to talk about what happens when you go from that nice little WebRTC prototype that you showed your boss or your customer or whatever to having to run the damn thing in production. What's it going to do to your network? What are you going to have to think about? How you're going to respond to it? So we want to give you a few thought points about that and how you should treat it. And the crucial thing is this one, is that it isn't the same. Although you can do that, that isn't the result you're going to get, because the bandwidth and the CPU use are drastically different, or potentially drastically different. And what's more, your customers may well be on mobile, on tablets, particularly with Android at the moment. Less so on iOS at the moment because it's not available, but that'll happen, or something will happen in that space. So you've got bandwidth and CPU issues, and those mean battery life on tablets. So it's a thing you have to think about. So you need to plan a deployment, and that's what we're going to try and help you do. And we're going to do it in two parts. So I'm going to talk about the architecture and the choices and try not to look quite that grumpy. And Dan is going to talk about the numbers, and he's going to draw some pretty graphs, which I am useless at. And actually, there are two really bad graphs in there, so you can tell how bad I am at it. So I'm assuming that if you're here, then you probably are, you're doing this commercially, right? You're not just doing this for a laugh. So the quality actually matters. You have a quality target you're trying to hit. Your customers care about. You're using Asterisk because you're here, or at least you've got a hybrid model, probably with PSTN and Asterisk and a few other things. That your calls are not necessarily symmetrical. So you may well have agents or internal users and external users and this kind of stuff. So it's not necessarily that one size fits all. That like everybody, you're on a tight bandwidth and CPU budget, because we all are. That's where the money goes, well, apart from the minutes. And that most of you are not doing video. Now, we'll talk about video, but it's not the focus of the talk, really. And I'm kind of assuming that you've got a clue, that you've used Asterisk, you've already got an installation with classic phones of some sort, and that you're trying to bridge out into the WebRTC world. So to do that, what I want to do is talk about some topologies. These are only typical topologies. They're not going to match everybody, but they're at least a discussion point. So this is the model that WebRTC was built for. Peer-to-peer video calls. Signaling taking one route. You have a web server, you have Asterisk, or a media server of some sort handling the signaling, and you've got the video and the audio going direct between the peers. That's the classic model, and I put SIP on that diagram, but it could be XMPP, it could be Jingle, it could be SIP over WebSockets, it could be anything, like a signaling protocol, let's say, but SIP is a shorthand for that, rather than being definitive. So that's the classic WebRTC thing, but actually that's probably what none of you are doing. What you're more likely to be doing is something like this, where you've got a bunch of agents who are sitting in front of, at the moment, soft phones, but you're paying a license fee for those, so it would be kind of nice to get rid of that and use WebRTC instead. So you're putting WebRTC on the agents' desktops, and they are handling calls in from the PSTN. So that's a classic model. You've got an app server, you've got an Asterisk handling the skills routing or whatever, so that's that kind of model. And then you might have it the other way around, that your agents we've got a mistake. Oh yeah, we flipped it, right? So now we've got the agents external. They're working from home, they're out on the road, whatever. So it's the same model, but it's coming over the internet. So instead of being on your nice, well-managed LAN with gigabit everywhere, and nice routers and everything, you're in some sort of space where you've got less control. You have some control in that, maybe you can specify a level of DSL or at least a country they have to be in, but you've got less control. And then there's the extreme case where the users are actually the guys outside. They're your customers, they're the Joe Blogs on the website, and they're trying to talk to your agents who are using desk phones. And in that case, you've got absolutely no control over the bandwidth whatsoever. You've got no control over the hardware they'll use, you've got no control over the bandwidth. All you know is that they've got a web browser because they got to your website. That's as much as you know. And so that's kind of the hardest case to deal with. And actually, in reality, it'll look like this. You'll have all sorts of stuff. You'll have fax and SMS and whatever. I'm actually not going to talk about any of that, but I just want to acknowledge the reality that my previous diagrams are oversimplifications. So what does that do? What does that mean in terms of the differences? How does WebRTC differ from, let's say, SIP? In the sense that, well, one of the key things is that WebRTC comes with ISA standards. So your WebRTC users will be able to go through a NAT. So that, if they're behind a home router or in a small office behind a router, there's a very good chance that the media will go through there without you having to do anything. There's a price that you pay for that, which is that, there's a small setup time, an additional setup time in setting the call up. And then the next thing is that traffic is encrypted. It's actually quite well encrypted, because that was how WebRTC was specified. But again, there's a price to pay, which is that decrypting it at the far end is going to cost you some CPU cycles. And then the other thing, and this is a subtle one, and I think it's easy to miss, is that because you're running this signaling over a public web service, it means that in effect some of your techniques for hiding your SIP service behind a proxy or something don't necessarily play the same way. So, your user's sitting in a browser and they're making a call from their home or, Starbucks or wherever, and that call isn't going over a VPN. It's not necessarily hitting a proxy. It might be hitting your Asterisk relatively directly. So you have to think about that architecture, make sure that you're not exposing yourself to attacks from the web domain as well as the SIP domain. So it's an extra domain you have to think about. And then I was saying that the media is encrypted. So DTLS handles the setup time, the key exchange at the setup time, and SRTP encrypts the call throughout the session. So again, there's some CPU cost throughout the session. There's CPU cost in setup, and then there's CPU cost in the session. And then there's the codec stuff. There are actually only 2 codecs that are available in WebRTC at the moment as standard. There's a whole argument about whether there'll be more, and often you will see others. But these 2 are the only that you can guarantee for audio. That's ULAW, which is, the one we're all familiar with. It's a bandwidth hog. It doesn't use much CPU. And it either works pretty well, or it works really, really badly. Like losing a few packets in ULAW is pretty disastrous. They can be patched, but it's still pretty bad. Opus, which is the newcomer, kind of has exactly the reverse. It potentially much lower bandwidth, much higher CPU use, and a whole lot of flexible settings and actually dynamically changeable settings for error correction and packet loss detection and repair. So you've got a whole set of things there that you can look at. And then you've got the video codecs, which I'm going to skip over pretty much. So when you're looking at audio, what is it that in those cases, the diagrams I came up with, what cases do you want to what codecs do you want to try and use for those cases? This is my recommendation. It's a set of recommendations, and the reasoning is kind of there. And it's basically around the idea of what your problem space is that you're trying to address. And so if you've got internal agents who are then ending up talking to customers over the PSTN, there's simply no point in enabling a wideband codec. You're just burning CPU for no reason, no use. You know, if you're in a low-loss LAN, that aspect of ULAW doesn't play either, so you may as well just stick with ULAW. If your agents are external, then you probably want to use Opus, and you can set it to a high bandwidth consumption because you're managing their DSL to some extent, and you're paying their bills, their bandwidth bills. So you may as well probably get the advantage of that. The external users, on the other hand, you know, so the guy in the coffee shop, actually you want to try and keep the bandwidth down because they probably don't have much quality bandwidth, and you want to use what you can in terms of compensating for the lost packets that you'll inevitably get when they are on the edge of Wi-Fi. So, you know, and they'll be sharing the other aspect, the critical aspect, particularly if people are calling from home, is they will be sharing that DSL with a teenager who's loading games or who's playing, you know, bursty traffic, basically, which means that although it may work fine for a while, it may drop out. So that's something that we're looking, you know, you need to look at very carefully because you're no longer managing that bandwidth as closely as most of you maybe are used to with the desk phones, for example. And a critical thing at the bottom here is, I'm speaking for me at Westhawk, Digium doesn't support Opus on Asterisk. So DTLS, there are a whole pile of options in DTLS. You probably don't need to change the defaults unless you're a bank or you have specific issues, but there are some options that if you have particular security requirements, you might need to think about. ICE is a really nice advantage as far as I'm concerned in WebRTC because it gets you through networks much more easily, firewalls in particular. And I'm assuming that most of you will put your Asterisk on a public IP address. So that probably means that you don't need a turn server. If you want to hide it behind a NAT or behind some other firewalling technology, you may need a turn server out in the cloud to reflect those packets. So look at your architecture and work out whether you have got a public IP for your Asterisk, and if you haven't, then maybe you need to think about running a turn server. And one of the things you can do to speed up the setup is to make sure that you're not offering internal IP addresses. Because the process for ICE is basically both sides try all of the IP addresses that the other side has sent them until something works. So obviously the more choices you offer that are invalid means that time is wasted trying all this stuff. So if you can tie it down to the one that's going to work, i.e. the public IP address that you're offering, that will help you. And try not to offer VPN candidates. If you've got a VPN that connects you to your SIP trunking provider, try to make sure that doesn't arrive in your ICE candidates because it won't work, but it'll waste everybody's time. And you may, under some circumstances, get a faster connection if you can tweak to using ICE Lite. I wouldn't recommend that, but if you're getting call setup times that are longer than you're comfortable with, that's a thing you can experiment with. But there are risks as well, and I'm not going to dive into the kind of whole depth of that, but it's a thing to look at. And the other thing to think about is that WebRTC is unusually asymmetrical, by which I mean that in a lot of the use cases, the two people aren't direct peers. So for example, with Amazon Mayday, you've got a video call in one direction and a screen share in the other. So you can see them, but they can't see you, but they can see your screen and you can't see theirs. So that's the bandwidth isn't symmetrical in both directions, which is unusual for, most VoIP things are symmetrical. And, for example, the baby monitor may have video in one direction, but not in the other. And security cameras, likewise, may not have any audio at all, or maybe one direction or whatever. So it's worth thinking about whether your bandwidth needs to be symmetrical in these cases. So what that means in practice is that you may have higher CPU use than you were thinking, especially if you're using Opus. And we'll come to some detail on that in a minute. And you may well have longer call setup times than you are used to. And that's something you may have to kind of try and mitigate. And if you use video, you will have massively higher bandwidth than you're used to with just running conventional, and even like on a little Polycom, whatever, video, that's quite constrained compared with how much fun you can have with Google Chrome on a big HD camera and screen. So Dan's going to talk about how we might monitor this and some numbers that we came out with.
Hi guys. So as Tim said, I've been working with Bespoke guys for the past like 10 months, and it's been hella fun. But trying to get stats out of WebRTC and being able to figure out how to improve your situation, your scenarios, is actually fairly difficult. As a matter of fact, I tried to set up a demo earlier on today, and Google had broken something. So we're constantly kind of trying to keep up with Google, with Firefox, in keeping up with their APIs, because it's ever-changing at the moment. So there are a few ways that you can do this. So you can access WebRTC stats directly out of like Google. So Bespoke has a package for this, but there are other packages out there. So if anyone's heard of Node, so NPM, there's a package on there called GetStats, and you put that into your browser, and you can get back some WebRTC stats. So you can find out what codec's being used, how much bandwidth is being used, what frame rates, etc. Then in Chrome, you've got WebRTC internals. So that kind of gives you the same information, but you can't take it programmatically. And that's where those other packages come in. And then you want to actually know about CPU usage, bandwidth usage on like your Asterisk server or whatever. So you can start using tools like CollectD and Graphite. There's a load of other ways of getting that information, but using CollectD, you can really simply find out how much CPU usage is being used, how much bandwidth is being used, how many kind of channels you've got in Asterisk, those kind of details. So Tim ran some scenarios and made some pretty graphs. You'll see in a minute. So he ran them against Asterisk 11.8.1 on a decent sized box, Chrome 38, up to 24 calls, and the graph shows bandwidth, CPU, calls, and time. So you can see here, so the blue line is the number of channels. The grey/black is the bandwidth, and then the orange is the CPU usage. So you can see, as you go over time, you can see that the bandwidth kind of massively kind of jumps, but kind of stops at a certain point. And it's the same with CPU.
The spikes are the setup. So the web pages was on the same machine. So as I was loading the web pages for each of those, you see the bandwidth spiking as it's pulling each of the pages in.
So that's ULAW. This is Opus. So you can start seeing a considerable difference between the amount of bandwidth and the amount of CPU. It's completely and utterly flipped. And then using the settings that Tim was talking about earlier with low bandwidth, high loss, etc., using Opus, you can see that you kind of get into this middle plateau. So you can start seeing how much of a change, like some of these kind of one-line settings can make to your user experience for your users and for your call center or whoever's using your service. So then I ran some scenarios using some of the stuff that we've done with Bespoke. So I'm running an Asterisk server on DigitalOcean in San Francisco, and it's a medium droplet. So it's 2 core, 4 GB of RAM, and like 40 gig of SSD. So I'd like everyone who can on their laptops or their Android phones, sorry iOS people, Apple doesn't love you. So if you can, let's go to that link.
Wow.
Now, yeah, now.
That's going to be harsh.
Oh.
So which one are we doing? We're doing the video.
So we are doing video. Okay, so hopefully, so that I can see. So we're seeing the left side fill up with people. So there's Tim, there's Billy, there's Martin, there's Kyle, not Dan Jenkins, a visitor, Samuel G. So this example is LAN to LAN, hopefully. So I'm going to be on the same network as you guys. And so it's LAN to LAN. So let's try this out. So who am I going to call?
Who are we going to pick on? Who's our volunteer?
So is that Samuel G? Am I? So I'm going to call. So how's my hair looking?
It'll do.
So I'm muted. I'm hoping someone's got a...
Samuel G should have a call.
Where is Samuel G?
You answered it?
Did you answer? Okay. You can see yourself. Oh dear. Well, I did say before this demo that it was a dangerous demo.
Let's try it on your...
And things were going to break. We knew things were going to break. So let's connect. So okay, let's cancel that. And so I've connected as foo.
That's right at the bottom.
That one?
Yeah, I think so.
So let's... Yeah, I know. I'm cheating a little bit. So I'm using my own phone. So I've got allow. So start call. Okay, great. So let's turn down my phone. Okay. So this is one of our example apps for a spoke, and then I've kind of malformed it a little bit with some hideous writing. So you can see right here that we're using the Opus codec. Audio sent is Opus. Video sent is VP8. I'm receiving audio and I'm receiving video. And you can see so this is this is getting it out of GetStats, out of Google, Google Chrome, and it's measured in bytes. So ignore any scientific whatevers, like KB is meant to be uppercase or whatever. So audio received is roughly 5 kilobytes per second. Video received is 250, 264 kilobytes a second. Audio sent, 5 kilobytes a second. So about the same. And video sent is about the same. That's because we're symmetric. We're sending the same information. So, oh, wrong way. So you can see that we're both sending audio, we're both sending video. And so generally you get the same amount.
But that's 2.5 megabits a second, which is, if that actually passed through your gateway and you had like 100 calls, you'd be spending serious money on bandwidth. Fortunately, WebRTC will try and get you peer-to-peer. But so there's serious money to spend on this if you make that mistake. And unless that's, of course, what you want.
So that's a LAN to LAN call. So let's just hang that call up. And what we're going to do now...
Am I still logged in?
Hopefully. You at the top there, Tim?
Yeah, go for it.
Which one?
Top one.
Top one?
Yeah.
So calling Tim. So Tim, just to kind of be clear, Tim's phone is not on the Wi-Fi. So it's going over the American mobile networks, which aren't like great. So I'm waiting for Tim to answer.
Okay. So I'm on 3G. I'm on 3G here, and I'm spending absurd amounts of money on it. So we'll do this reasonably quickly. But you can see that the video rate is hugely down. Like it's right down it's detected that there's not a huge amount of bandwidth available, and we're down at Oh, we've lost it completely now. That's probably my package cut out. But you could see that you were about an order of magnitude smaller video bandwidth being used because it detected that it wasn't available. So the point there is that WebRTC is quite responsive to what's available in terms of bandwidth. And if you make high quality bandwidth available, it will use it. It will suck down every bit you offer it. But on the other hand, it will back off if it's not available.
So I'll leave that demo up for a couple of days, a week maybe. It's currently using like bespoke minutes. So I probably got to make it a little bit more open to being there long term. So we'll leave it up and we'll try and kind of make it so that it can stay up. And so you can actually you can go and use it on your devices, etc. And you can actually see how much bandwidth is actually being used and how much that's actually going to cost you if you don't think about these things and put like these one-liners in. Okay. So the next demo is quite risky. Is Mr. Bodie in here? No? Well, Mr. Bodie should be in here because this is a dangerous demo. So I would like, this is going to be fun. Everyone go to this address and hopefully this is going to work. So bit.ly/DTs dash asterisk. So someone's already got that. Okay, hold on.
So
my mouse, where's my mouse? Okay, so
let's hit the stats.
So let's, first off, I'll show you what everyone should be seeing. So what this is doing is, you should all be pressing connect. And hopefully you'll all hear Alison saying a load of jargon. Right? They're phrases. Wrong link.
Can we flip back to the URL? I didn't type it in quickly enough.
URL, so bit.ly /DT dash asterisk. Has everyone got that? Yeah? Okay. So let's take a look at, so these are the pretty graphs that are coming out of Graphite right now. So let's disable Houdini for a second. Okay, so this is coming straight out of my Asterisk box on DigitalOcean. And it's in San Francisco, so it's not terrible latency.
So you can see you've all pulled in.
So this graph here, this is CPU usage. This graph here is CPU, so that one's system, this one's user, this one's the amount of memory that's being used. This one is load. This one is something or other, collect D. Can't remember. This one is bandwidth, and this is the amount of calls. So we can see that there's around 50 calls going through Asterisk at the moment. Okay, so what is actually happening here?
What was the load with 50 calls?
So load with 50 calls
Not much.
is not much apparently.
But that was ULaw.
So let's hold on. I haven't selected auto refresh. Yeah, so it's not very much. Okay. So what this is doing is using Chan Bespoke that we released earlier on this week. So we're using Bespoke's infrastructure to create a WebRTC call into Asterisk so that you can do whatever you want with the call. So currently that's playing back Alison, lots and lots of different kind of versions of Alison. I was hoping to hear kind of this echoing.
Yeah, turn the volume
Alison.
up. Do it again and turn the volume up.
Yeah.
We want to fill the room with Alison
we wanna hear
talking
Alison.
nonsense.
So we've gone down to like 20 users. Okay, so that's starting to sound better. That's starting to sound much better. So the point of this is showing that you can connect WebRTC to Asterisk, and you can see that load's just gone up again. And the amount of memory has gone up again. So we've got some more connections coming in. So just kind of to tell everyone, I hope this graphite box hasn't died. Maybe it died. Okay. Well, anyway. So, oh, it's back. So these stats are coming out of StatsD. That's coming out of Asterisk. So that's in Asterisk 12. So this is all kind of stuff you can go and do today, like really, really easily. And you can know how many calls are coming into Asterisk. You can know how much bandwidth is being used, etc. And you can get more stats out of Asterisk. I just ran out of room. Okay.
So in the context of WebRTC, this is the kind of thing you should be putting out in your test deployment so you can see what you're running out of and then go back and tweak the codecs based on that kind of thing.
Okay. Okay, we've stopped listening to Alison. And so that's it in terms of demos and graphs and kind of showing you the basics in terms of what you need to do in a production environment to make sure that you're not capping yourself, etc. So Tim talked earlier about turn servers. Turn servers cost money. So they're resource intensive, they're bandwidth intensive. So I think, what's the stat? Like 15% of WebRTC calls can't go peer-to-peer.
Yeah, but those, if one end is an asterisk, that number goes hugely up.
Exactly, because most people have their asterisks behind a firewall. So imagine, how much bandwidth were we talking about there? So as an example, the other day I was on a call, WebRTC call, and accidentally I was kind of in the wrong network topology, and I ended up going through Bespoke's turn server. And in an hour, I used 3 gigabytes of bandwidth. So if everyone uses 3 gigabytes of bandwidth per hour, you start getting very, very, very expensive within like AWS's network or whatever. So that's kind of the moral of the story. Go and make sure that you're not abusing stuff that you can kind of help and prepare for. So there's the link to the examples. That's a fork of our Bespoke examples. I'm Dan Jenkins on Twitter, Dan_Jenkins on Twitter, Tim Steely_Glint, and we used Bespoke as part of this. Has anyone got any questions? We've used some images. Here's some links.
How do you go about doing that? Is there a JavaScript API to tell the browser to go high bandwidth or low bandwidth, enable forward error correction, disable forward error correction? Or do you just have to patch asterisk to make the SDP bend to your will? Or
Right. So there's 2 ends to this equation. If you look at the Opus patch, so Digium people, cover your ears, you don't know about this. There's a patch on GitHub that allows you to add Opus to Asterisk. And that tries to detect what the other end is offering. So it looks at the
SDP.
No, it actually looks at what the channel's set at whether it's 8 kilohertz or 16 kilohertz, and then assigns that to what it will, to the configuration of the Opus codec. What actually sometimes happens is it changes its mind and reassigns it. So it tries to get that right automatically. So if you are using PSTN, then it should get that right. So that's the end, the asterisk end. But yeah, at the browser end, you need to fiddle with the SDP. Currently there's no settings for tweaking that. You just have to edit the SDP, which is not that difficult, but it's annoying. No, that way Asterisk will look after that, but what you set as your local settings, so the set local description. So the process is that you ask the browser to give you a local description, which you then set. Okay, but you can change it on the fly in the meantime, and that you can add a bandwidth cap on it at that point, and that will make a big difference.
So there's an awful lot you can do by munging SDP. So WebRTC has data channels, and if you just leave it by itself, then you can only send so much data per second. And that's kind of just a default. But you can go into the SDP and you can change that. There's a ton of stuff you can change. And hopefully the browsers are kind of catching up to the fact that we all want to kind of have more control. And hopefully very soon they'll be giving us more control without kind of playing dangerously with SDP. Any other questions? No? Okay, great.
Feel free to grab us in the corridor and ask us questions or tell us off or whatever.
Thank you very much.